Yeah, hi Josh. Thanks for being on this podcast of the Streamlit Cookbook. Yeah, could we start by you introducing yourself, please?
Yeah, definitely. Thanks for having me. So I'm Josh. I'm a developer advocate now at Snowflake, and before Snowflake, I've been building Trulens as an open source project to evaluate and track LLM maps with a startup called Trera that was recently acquired into Snowflake.
Awesome, awesome. Yeah. Yes, could we perhaps start by like a short introduction about TrueLens?
Yeah, definitely.
Mhm.
So we founded and built Trulens with the idea that LM applications have a ton of knobs to configure when you're building them. You're playing around with the search configuration, the generation. Maybe you're trying different temperatures for the LLM. Maybe you're trying to decide between a big state of the art model or a really small, lightweight model. And while there's lots of public benchmarks on these things for kind of public data sets, you really want to know what performs the best for your setting, for your domain, for the queries that are most like your production traffic. Um, so Trillens works to evaluate your application on your query. So you can set up some metrics that matter to you and then look at the performance on those metrics. And this is a bit of a challenge in the LLM world because we didn't have a lot of predefined metrics like we did in classical ML. So one approach that we've taken that's now become pretty mainstream is this idea of an LLM judge. So this is the idea where we can have an LLM that looks at different parts of your application and then decides if that step of the application's executed trace is performing well. So if you take one example, we could evaluate the search results and say, is this context chunk that was retrieved by a retriever relevant to the original user's query? So that's like one example of an LM judge metric.
Right. And so theoretically, we could use such data that we obtain from this to kind of fine tune further LLM models. Is that correct?
Yeah, definitely.
Mhm.
Yeah, fine tuning is a really great use case
Mhm.
to take this data. And another way too is just in the development stage, being able
Right.
to really easily compare as you're kind of changing some of those
Mhm.
knobs.
Oh, okay, awesome. What are kind of the metrics that we could measure?
Yeah, so one of the really common use cases
Mhm.
for people building LM applications is this idea of a RAG.
Mhm.
So there's really two steps in the RAG. It's the retrieval or the search, and then the generation. And the common metrics for these are going to be kind of connecting each step of this application. So the first would be that like search relevance or context relevance, measuring the effectiveness of the search, and then the second metric we would use would be groundedness, and that checks to see how well the LLM is sticking to the facts that are present in those search results. And then the last would be answer relevance.
Mhm.
And answer relevance is just looking to see, are we actually answering the user's question as intended? So that's kind of the basic metrics for RAG. But this can be kind of a pretty long list depending on
Mhm.
do you care about the helpfulness of your application? Do you want it to be safe, or maybe you have some like business logic or a particular style you always want the LLM to respond with? So those are all things you could check as well.
Okay, awesome. As kind of like a prelude, I think like you'll be probably demoing like the use of TrueLens with Streamlit. I was just wondering like how could Streamlit be used to integrate or accept input from TrueLens, and how could it be integrated into a kind of like an app?
Yeah, that's a great question. So Streamlit is a really nice way to build really easy UX with Python, and we've because a lot of people are building applications directly in Python, we wanted an easy way to kind of add those metrics to show up directly in your chat experience. So we have what we call TrueLens components, which is a bit a kind of standard Streamlit component that you can call and add really easily to your Streamlit app. That's going to show things like an evaluation score or a trace of an application, or even a full leaderboard of application results.
Oh, okay. Wow. Okay. And how could one store such data obtained from the app?
Yeah, so you can configure TrueLens to log and store the evaluation results in any SQL Alchemy compatible database. So that could be as simple as a small SQLite database hosted locally, or it could be a remote database like Snowflake or some other database service that you're connecting to.
Awesome. Awesome. Right. Yeah, I guess the viewers would love to learn more about TrueLens. Yeah.
Awesome. Yeah, so I can share. I'll just kind of quickly flash the home page so folks can know where to find it and learn more. So this is trulens.org. And this is where people can learn a lot more about TrueLens. Check out our docs over here. Check out, we have a really big cookbook of all kinds of different ways you can use TrueLens, along with some component guides that also can be really useful on figuring out how some of the inner workings of how things work and how to get things set up for your setup. And then now I'll just kind of quickly jump into the demo. So here I have a chat application built in Streamlit. And at first glance, it seems pretty simple. It's kind of a standard. You enter some text and then get a response out. And you might even guess that this is a RAG application based on the phrasing of the subtitle. But there's a couple kind of neat things that I have added to the app to make this interesting. So let's just try submitting a basic question about when the University of Washington was founded, and we get this response back that it was founded in 1861 in Seattle. But what you also see is this clue to see the trace of the record. So this is one of those TrueLens components that I talked about, where we can actually see all of the different steps that our application is taking. So in this case, it would be the retrieve method and then the generation. So if we look at this execution trace, we can see exactly how the application is working. For example, in our retrieval step, we're sending this query, and then we're getting four context chunks back. And then if we look at the generation step, you see we're sending a query and our four context chunks as a list, and then we're getting a return of our LLM generation. And then the second thing we'll see, in addition to the trace, is our evaluation results. So here you see the three metrics that we talked about before: groundedness, anti-relevance, and context relevance. And the first thing you'll notice is that context relevance has a lower score. And what we're doing here is we're looking at each of the four context chunks and then grading the relevance compared to the user's query. So what you see, based on the coloring along with the scores, if we scroll to the right, is that we're getting one relevant context chunk and then three irrelevant context chunks. And this is kind of bad for a couple of reasons. So one is that we have the potential to confuse the LLM in giving it a mix of relevant and irrelevant information. So it might kind of mix up and combine different things in trying to answer questions, especially maybe a harder question. And then the second is we're just incurring unnecessary generation costs because we're charged. LLMs generally charge for both input and output tokens. So we have all these input tokens that we don't need and we don't need to be charged for. So that's what I'll point out there. And then the other thing I'll point out here is that in addition to the score, you'll also see some reasoning on why this context chunk is not relevant to the user's query. So the way we're doing this LM judge is that the LM is being prompted to first produce some reasoning about why this context chunk is or is not relevant, and then produce a score. So this results is one way we can help align the LM judge to produce reliable and trustworthy scores. And it has the side benefit also of us humans being able to more easily figure out how the LM judge is making that decision. So next, I'll point out the second feedback function, our groundedness score. So this is what we talked about before, where we want to look at the LM response and evaluate for the claims that it's making. Are those attributable to the evidence that is in that context chunk, or are they kind of hallucinations on top? So if we look at this full LM response, what you'll see is kind of two things. So the first thing is this greeting. It says, "Hello, I'm happy to help." And that's really not a fact that we want to fact check. That's not a claim. Um, and we really want to focus just on grading the accuracy of this University of Washington being founded in 1861 in Seattle. And our LM judge knows this. So what you see when we look at the evaluation is that there is no evaluation of the greeting statement. And instead, we're just focusing only on the facts that need to be checked. And in this case, this is doing pretty well. We have clear supporting evidence from the context chunk, from the source that supports the LM or the claim that the LM is making. Last, I'll just click on the third evaluation. So we all see all three portions of our RAG triad. So here we're looking at answer relevance, and we can compare the prompt and the response, and then along with a score and the reasoning that tells us that this response is indeed directly answering the question posed by the prompt. So now we've kind of walked through some of the basic ways we can evaluate a RAG application. I'm looking at answer relevance, context relevance, groundedness, and trying to get a feel for how well this application is performing. The next cool thing I want to point out about this app is that we can turn on what's called context filter guardrails with this toggle up here on the top. So if you think back to looking at our context relevant scores, what you saw is that we had 3 irrelevant chunks and then only 1 relevant chunk. And this was causing kind of unnecessary cost in generation from those input tokens that we'd really like to avoid. And one way we can do that is through context filter guardrails. So what this is going to do is that we're going to evaluate each context chunk and score it for its context relevance. And then we'll kick out any of the context chunks that are not super relevant to the user's query before they get passed to the generation LLM. So now if we try that same question again, when was the University of Washington founded? Now you see a context relevance perfect score of 1, and we actually only see 1 context chunk being scored here. And if we look at the trace and the retrieval method in the trace, you see we actually only have 1 context chunk that's retrieved and only 1 that's passed to the LLM. So this is really good. That means the context filters are working as intended and kicking out our irrelevant context before they get passed to the LLM. And then the other thing you'll notice is that this does take some kind of additional cost in terms of time to evaluate when we're moving these LLM judge into the execution time of the app. So you'll see the retrieve part of the application taking just a little bit longer because it has to evaluate each chunk before it gets to the generation. So now that we've tried maybe what's like an easier question, let's try a bit of a harder question. So now let's ask if Washington State has a Starbucks on campus. And when we see the response, we see that based on the information provided, we can't determine if Washington State has a Starbucks on campus or not. And if we look at groundedness, we actually see we're pretty happy with this response because it's actually saying what it doesn't know. So this is kind of the ideal response we're looking for. We want the LLM to be able to say when it does and when it does not know, rather than hallucinating. And if we think about the groundedness, this is actually the evaluation we want as well, because we're looking at these claims that the LM is making, or these statements, and they're kind of correctly saying that the LM can't determine if Washington State does or does not have a Starbucks on campus, because it was not given this information in the context. So our groundedness evaluation knows that this is an abstention, or the LM saying that it doesn't know, and it scores it with a 1. Now, just for comparison's sake, let's try that same question without the context filter guardrails and see how it does. So this actually seems like it is doing pretty well. It mentions Starbucks being headquartered in Seattle, and a few other things. But we can kind of see the evaluation metrics here. If we look at context relevance, we're actually all 4 context chunks are not relevant to this user query about Washington State having a Starbucks on campus. But overall, as we're kind of trying and experimenting with these different queries, we start to get a sense of how well the RAG is performing. I think that's probably a good place to stop if you want to plug in, or maybe we can go through the code if you have any questions.
Yeah, sure.
Before I get into it.
Yeah. Right. Yeah. A quick question. When we're using the context filter, does it incur additional costs, or would the cost be the same with or without the context filter?
So it occurs additional cost during the execution of the app.
Mm-hmm.
But if we're doing the evaluation either way, and we're just choosing whether to do it kind of after as like an offline evaluation, or as guardrails, it would be the same.
Oh, okay. Right. So as for the LLM judge, is it applying another LLM model to evaluate the generated response and then kind of like giving it a score?
Yeah, exactly. So the way I would think about this, because a lot of people have this question, which I think is pretty natural, is like, I don't really, the reason I'm using evaluations to start with is because I don't trust the LLM. So why should I trust like another LLM to grade it, right? And the reason I think this is a reasonable old claim to make to use an LLM judge is because the LLM judge is actually kind of performing a different task than the original generation LLM. So the LLM judge is giving a much more confined problem, where it's given maybe like a query and a statement, and it's just saying, is this relevant or not relevant? And that's much easier for the LLM to do than to actually try and answer a question from that context.
Right. And how many LLM judge are there?
So Trulens allows you to kind of plug and play and configure any LLM you'd like. So you can choose as big as like your biggest SOTA models, GPT-4o, or as small as maybe like a Llama 1B. So it's really up to you.
Okay. As for the judge criteria, do you, as a user or developer, do you specify that? Like maybe you give a certain set of criterias based on the prompts? Do we need to define that?
Yeah, that's a great question. So out of the box, Trulens it'll come with the criteria for these metrics. So things like context relevance or groundedness. But we also provide an easy way to customize these the prompting and the criteria that goes to the LM judge. So if you want to kind of change certain parts of that criteria, or like add new sections, or remove it and change it altogether, we make it really easy to do that.
Awesome. Yeah, that's pretty cool. Another quick question is, so theoretically, if we, like recently Streamlit has the audio input, so theoretically we could take like real-time audio and then apply TrueLens to evaluate on statements, and then um, perhaps do like a sentiment analysis, and or even like do a fact check. Would that be possible?
Yeah, I think that should be possible. I think the like out of the box way to do it would be if you're like transcribing the audio. But I think you could also plug in like a multimodal model as your judge, and then use that for scoring as well.
Okay, awesome. Right. Yeah, thanks for clearing up all of the questions. Yeah, I guess we're ready to continue.
Cool. Yeah. Now we can get into the code. So developers' favorite part. So
Awesome.
uh, if you're not super familiar with Streamlit Cloud, you might, or Streamlit Community Cloud, you might know or not know that any Streamlit Community Cloud's application code can be accessed with this like GitHub icon in the top right. So that's what we'll do here. And now I'm on just the application code powering the application that we saw just a second ago. So you see the title, the subtitle, and then we can kind of get into the meat of the code here. So the first thing I'm doing in this application setup is I'm creating a TrueLens session. So this is going to be our logging session. By default, if we pass it no arguments, TrueLens will create a SQLite database on your local device, or in this case on Streamlit Community Cloud. But if you want, you can also kind of pass in any database to connect to and log to, so you can send all your traces and evals that way. But for now, we'll just use the SQLite. I can talk about this toggle in a second, but first we'll talk about the meat of the application. The meat of the application is that it's going to take in this input text and then return a response. And we've added this with filter true rag as a recording with block. And this is what's doing the actual recording of your application's traces and kicking off the evaluations. So this filter true rag is something that's set up in this base.py, and we can go through that in a second. But that's acting as our context manager, our recorder of each time your application runs within that with block. So here we're kind of choosing with or without filters, and then we'll run and record the application's trace. And then we get to the part of using the TrueLens components. So here we'll see two. So we're creating an expander with Streamlit that says see the trace with this record with the cute little eye emojis. And then we can create a TrueLens trace by simply passing the record from the response. So that's taking the execution trace and then generating that kind of nice clickable UI, so where we can click around and see kind of the inputs and outputs of each of the different internal components of our app. And then the second thing is the TrueLens feedback. So that's those nice pills showing the scores and then the breakdown of our evaluation metrics. So all you have to do to enable these is just pass through the TrueLens record and then call TrueLens trace or TrueLens feedback to create them on your UI side. So this is the code that powers the application. And then I'll just click into base.py where I'm creating some of the more TrueLens native pieces. So here we have the actual RAG application itself in this RAG from scratch class. And it has kind of the methods that we saw when we looked at the tracing, our retrieval, and our generate completion. And we're tagging each of these with this @instrument decorator. So this is a TrueLens decorator that when you add it to any method in any Python class, Trulens will record the input and output of that method. So this is all we need to do to enable the tracing here. And then the second thing we'll do is we'll create some feedback functions. So these are going to be in feedback.py. So here we're creating groundedness, answer relevance, and context relevance. And these are going to be powered by the GPT-4o Mini. So that's the LLM we're choosing to use as our LLM judge. So going back to base.py, we've created our RAG application with those at instrument decorators. We can give it an app name, an app version. We'll pass it a list of feedbacks. So these are our evaluation metrics. And then that's all we need to do to take this true RAG and then import it back in app.py and then use it as our context manager to record all of the different traces and kick off some evaluation metrics to compute. The last thing I'll talk about while I'm in the code here is the context filters that we saw before. So these are also enabled via a decorator. So we'll import context filter from Trulens core guardrails. And then we can pass it any feedback function. So any way to just like take some text and then get a score. We'll pass it a threshold. So here we're saying if the score is at least 0.75, then keep that context chunk. Otherwise, filter it out. And then the last is we need to tell it exactly what is the keyword argument for the user's question. So we could just pass those three arguments and then add context filter to our retrieval method. And then that's automatically going to take this list and then filter it down to only the relevant chunks as part of our application's execution. Was that all crystal clear, Chenin, or anything I can double click on? I think I lost you on mute.
Oh, sorry. Yeah, for the feedback.py, are we also using that in the app?
Yeah. So feedback.py is where the feedback functions themselves are set.
Mm-hmm.
So we're going to set our LLM judge provider as GPT-4o Mini. And then we can construct our feedback functions. So there's kind of two main parts to this. So the first is what is the LLM, and then what is the criteria we want to use. So for groundedness, we're going to use some out-of-the-box criteria for measuring groundedness that's accessed right here. And then the second is which parts of the application's execution trace do we want to evaluate. So here, what you see is that the first argument that we want to pass to this feedback function, and it really is a function because it takes these inputs or these like parts of the application execution trace and then outputs a score. So the first argument we want to pass in is the return of the retrieval method. So that's what we're specifying here. And then the second argument is the output of the application. And then likewise, if we look at context relevance, the first argument is going to be the input of the full app. So that's our user question. And then the second argument is going to be the list of returns from the retrieval method, because we want to evaluate each context chunk compared to that original user query. So we'll define each of these feedback functions, and then we'll create a list of them, and then we'll just take this feedbacks and then import it into base.py. So we do that right here. And then those feedbacks are again passed when you create the true custom map recorder,
Hmm.
just in its argument right here.
Hmm. Right. And you did mention about the score. In computing the score, what's the range of the score?
So the when we kind of give the criteria to the LLM judge,
Mhm,
by default, we ask it to score from 0 to 3.
mhm,
Um, and that's a kind of pretty nice range that allows kind of some different levels and more options um, for the human to understand like exactly how good is this response or this context chunk, but also is like not too big where the LM like can't decide.
mhm.
And then no matter what, even if you change this where the criteria is like a bigger range, we're gonna always scale it down and normalize 0 to 1.
Mhm. Right. Oh, okay. Right. And what would be a good score? Like, would one be considered good?
Yeah. One would be best, 0 is worst, and then it really depends on kind of your setting. If like you think you only need scores like above zero point 0.9, or maybe in like a lower stake setting, maybe anything above like zero point 0.6 is good.
I
So
see.
yeah, that part can like really depend, but generally 1 is best, 0 is worst.
Okay. Right. Oh, okay. Based on a normalized scale, 0 to 1, and then like you mentioned about like the scale of 0 to 3. So that's like the unnormalized version, right?
Yeah,
Oh,
exactly.
okay.
So we ask the LM, we say like, uh, choose how relevant
Mhm,
this context chunk is. 0 if it's not relevant, 3 if it's the
mhm,
most relevant, and then we'll take the number it responds
mhm.
with, and then scale it down to 0 to 1.
Okay. Perfect. Crystal clear. Thank you.
Also,
Yeah. Mhm. Oh, and how about the vector store?
yeah. Good question. I totally skipped over that. So I realize this might be kind of small, so I'll zoom in twice as well.
Mhm.
Um, so the vector store we're using here is ChromaDB. So I'm setting that up here, and then the data is just it's like really small.
Mhm.
It's just some text that I'm creating here, but obviously this vector store and retrieval method could be kind of as big as you want. I'm using an Ada 2 embedding, and then adding kind of 5 context chunks to my Chroma vector store, and then when I get over to the actual app, I am retrieving with a top K of 4 from that vector store.
Mhm. Right. Yeah. Okay. Yeah. So that's is there any additional features that you would like to highlight?
I think we had a nice coverage. I don't want to leave people with too much to chew on, so I think we had a nice set of things. I guess to kind of summarize the full set. So we talked about some of the different evaluation metrics you might use to evaluate RAGs,
Mhm.
from our search quality with context relevance, to evaluating hallucination with groundedness. Um, we talked about how to use context filters, which is like taking those offline evaluation metrics and bringing them inline into the application itself, so we can actually block the irrelevant chunks before they get to the generation step. And then last, we also talked about how to take some of these evaluation scores and observability features and add them as like UI widgets into a Streamlit chat app.
Mhm. Awesome. Awesome. If users or viewers would love to learn more about using TrueLens, where could they go?
Yeah, definitely go to trulens.org, which is our kind of homepage. And then also Trulens is totally open source, so you can go to the GitHub page and see all the code and really explore it to your heart's content.
Mhm.
And that's going to be also linked on trulens.org. So I can just flash that one more time. So the GitHub is going to be linked right here. Give a star. And then we also have a Slack community with about 2,000 folks in there, talking about how to use TrueLens, how to evaluate RAGs, how to evaluate agents, and all that good fun stuff.
Mhm. Awesome. Yeah, I believe all of the viewers would love to play more on this. And yeah, links to all of the resources mentioned in the video will be included in the video description. Yeah, thanks, Josh, for sharing with us on how to use TrueLens and also gaining observability of LM maps.
Yeah, absolutely. Thank you so much for having me. It was a ton of fun to collaborate on this.
My pleasure.
Awesome. See ya.
Bye.